So, hello student, welcome back, and today we are going to discuss paper 2021 February March paper, variation 62. Let me turn on my light. Yeah, that is better. No wonder I see everything is like darker. Okay, let's look at this question. A student investigate the rate of respiration in a cell. So this paper is about experiment, and it depends. The question can ask the experiment that you already study in the textbook, or the question can ask you the question that you didn't study in the textbook and you need to think by yourself. So it's good lah, if you can think by yourself, so you can next time you can do your own experiment for your business, like who want to buy my product, you also can do the experiment, what product people like, then it will help you in your business, because you don't want to do something before you really, we call this business planning. Before you plan, you say I want to sell something, then eventually it will fail and you lose a lot of money. So business actually, they spend a lot of money in ethnography, they spend a lot of money in the analysis experiment of product. They really spend a lot. Because when they launch this product, then they want to make sure it is a successful product. Student investigate. Okay, so now let's look at the science experiment. So much different from the business world. As the rate of respiration in yeast cell. Okay, so okay, you know lah, animal cell. So there's a respiration. Yeast cell is an organism, microorganism similar to plant and animal cell. Okay, the student provided a yeast suspension. So it's a yeast suspension. Is provided with a yeast suspension and some yeast suspension that have been boiled. So the boiled one probably will be dead lah, because you boil the microorganism, correct or not? We consider yeast as microorganism. Once we boil it, probably it will be dead. Maybe you want to eat it, I don't know. A yeast cell respire the produce carbon dioxide. Yeah, of course, respiration produce carbon dioxide. Describe observation. So if you put it with a glucose solution, it will produce gas bubble. So you will get 1 mark for this question. Okay, let's should I read this one? But very fast lah. Okay, he want to test 3 things. So you can pause and read by yourself lah. So basically he put the water and yeast for the test tube A, and glucose solution and suspension, glucose and yeast lah for test tube B, and glucose and boil. So probably what we can see is, we can imagine what is going to happen next is there will be a lot of bubble in test tube B, correct or not? Because there is glucose and yeast. Probably the glucose and boil yeast no bubble because you die already ma. And water and yeast also probably not that much because there is nothing for the yeast to eat. So we can see that B will be the most, either A or C will be the least. Our prediction, our hypothesis, because hypothesis means what? It's something that we assume but we haven't tested it. It's not a conclusion. Though we say our experiment for IGCSE up until IGCSE sometimes we reject the hypothesis. Hypothesis is rejected. Yeast does not produce carbon dioxide, for example. So hypothesis, so we already got our hypothesis, but we haven't do our conclusion yet. Then they put it upside down. So I think it's very good. So we no need to think. So when I read this experiment, I think it's very good. I no need to think. So they put it upside down. And of course, if up there got a lot of volume of gas, then we know the rate of reaction is faster. If there is no gas, probably there is no rate of reaction. So we have a little bit of gas bubble at here, correct or not? Because when you, no matter how fast you turn, sure there will be some air go inside, correct or not? Even though you make it full, when you turn like that, sure there will be some bubble that go inside. So there will be a bubble. Okay, and what they do next? So they measure it and they want to get the observation, correct or not? You want to see, then you just put there for maybe 2 days, 3 days, observe, another 4th day you observe, another 5th day you observe. For example, I don't know how you want to do the experiment. You want to do it for hour, daily basis, weekly basis, monthly basis. I don't know, up to you. Okay, I cannot say wrong. It is still correct, but you don't say yearly basis lah. Yearly is it miss the more already go. I think daily or weekly will be good. Okay, so this is the guesstimate. So basically we know what's the experiment about. So let's look at the observation. The result is measured. Of course, I know it's a paper, so the student print it out, but so there will be some slight difference in the measurement, but the answer will be 63 mm.
Forgot to convert.
Yeah, so you be careful because here is already mm. So make sure that you just write 60 lah if you print this paper out, but the answer marking scheme is 63 because due to the scaling of printing. So when we talk about this, then I'm thinking like, should I measure like this or should I measure like this? Something like that. I'm thinking and thinking and thinking. Then that is why I cannot skip question, because actually just now I accidentally skip. Then I look at the question, all is here. Height of liquid to the most bottom of the test tube. So if you do it, you buy your ruler and you will probably get 60 to 65, but it's alright lah, because you print it out. Unless you print it out, there's an option 100% follow the scale, then you will eventually get 63. The student did mistake. The student thought it's cm, so he put 6, but you won't get any mark for this one. Test tube B contain glucose, test tube A contain no glucose. So of course no glucose, probably there is not much of reaction. Use this information. Let me make it bigger a bit. Let me adjust. Use the information to explain what difference of result between A and B. So let's look at A and B. A and B. So 63 will be higher than 18. So that will be the, okay, so it's higher. So why is it higher? So correct lah, like what you say, because it got glucose. So explain why so maybe we can say that yeast will react with glucose to produce carbon dioxide, anything lah. So he asked me to explain so I explain lah. So I say yeast will react with glucose to produce carbon dioxide, for example. This is how you explain. But of course you can see that you can say because test tube B got glucose, but this will be the better answer lah, because the marking scheme also say something like this so I just follow. Will I give wrong if students say because test tube B got glucose? I think probably I give wrong, because this is really a better explanation because yeast will react with glucose or to produce carbon dioxide. I still think this is or maybe you say glucose is needed for respiration. That is a better explanation. Explain if you say just got glucose, it is still explained, but you assume the person know that there is a respiration is going on. So if you understand what I mean I hope that you understand what I mean. Okay, test tube C is used as a type of control. So of course, control variable, I say many times to make it more fair. Yes, of course, control variable, we want to make it more fair, correct or not? Let's say I want to know plant need water to survive. So I take plant A got water, plant B no water, and then the control variable, I will say the same type of plant. I cannot use one cactus and one mangosteen. Test what? Of course the cactus without water also will survive. So this is to make the experiment more fair. Yes, I know, but you cannot say to make it more fair. You need to explain how it can make it more fair. Then I will say, I cannot use cactus because cactus actually cactus just need to be watered once per year, for example, or so that you explain the answer. So this is a too general answer. I won't say it's wrong, but it's too general. So why we want to put a purpose? Okay, yes, to make it more fair by how, for example, to find out if glucose reacts on its own. So you assume that you want to put the glucose with a distilled water, correct or not? We look at the experiment, test tube C. They are using so up here, glucose solution and boil yeast. Okay, so probably there's glucose and boil yeast, and we are assuming the yeast is already dead because you boil it. So we want to know whether that the glucose react by its own to produce carbon dioxide, for example. But of course I know I know that you know that just by glucose alone it won't produce carbon dioxide, but that is the purpose of control variable You want to make it more fair by how, so you just explain it. Explain why is it difficult to get accurate value. Human error, yes, but I need to be more specific a bit. For example, I can say that rounded bottom at the test tube make it difficult for the person to measure, correct or not, because it's round. Actually, human error is correct, but the better answer in the marking scheme is meniscus of water. So this one is a superior answer, correct or not? You can say that, yeah, human error, how the person fall down. But if you talk about meniscus of water, or the person did not see the water perpendicularly, something like that you make sure that you explain the answer. So human error, you won't get any mark. Even the other experiment you don't just say human error, you say like what error, parallax error or what error, you need to explain. So this one also didn't get any mark. Of course, I just follow the marking scheme If you do for year maybe standard 6 or year 6, then probably you will get correct because it is standard 6. But now you already grow up. I'm sure when you go to university, this answer will be wrong. There will be another more specific answer as you go to your university. Describe to test to find out the gas is carbon dioxide. So in order to test carbon dioxide, we use lime water, and it will turn milky. No need to write calcium hydroxide This, even book didn't say it. Okay, just write one answer enough because actually I put this wrong, but after that I put it correct back, because if you put this two, means two must be equally correct. So means if one wrong means you straight away get two wrong. Calcium hydroxide is the chemical name for lime water, so that's why it is still correct. But in exam, don't do that because there's no point taking this risk, because let's say you're not sure, you put two, but either one is wrong, you totally get all wrong. So not worth it not worth it. Just choose one. Lime water is commonly used in the textbook. Calcium hydroxide is I seldom read in the textbook No usually book textbook, your science textbook, usually how to test the lime water, carbon dioxide, lime water, so we just follow the textbook. State one variable that keep constant. Okay, what's the thing that keep constant? The time, glucose concentration. The marking scheme say concentration of yeast, but amount of yeast I still give correct I put benefit of doubt because the amount of yeast actually mean the concentration of yeast, but the marking scheme is concentration of yeast due to BOD, I just give correct. The teacher does the experiment similar to 40 degrees Celsius. Investigate different of concentration of glucose. Okay, so now they want to test the glucose. The teacher measure the volume after collected after 5 minutes. So the whole experiment is repeated by 40 Celsius. So the percentage of glucose solution is to study the different concentration, not the different temperature. I thought it's different temperature. What? Okay, so they want to study, of course, higher concentration, the rate is faster, correct or not? So we put 6 is slow, we put 11, it is very high. So if the glucose solution is high, the volume of gas collected will be high. But I won't say like that. I would say like if the glucose solution concentration is high, the reaction that taken place is faster. So these are the something that you want to use to measure the maybe the rate of reaction rate of reaction. Sometimes they give in the question okay, investigate the effect of concentration against the rate of reaction, something like that. Sometimes the question give the answer. Okay, the result for 8% is anomalous, suggests what might have caused. So of course we know that this one will go up higher. As it go higher, this one will go up higher. But this one is special because 3, 8, then suddenly it go behind, then it go forward. So what is wrong in this experiment? So we can say that actually the answer is okay, so you can say maybe less glucose why? Because maybe you can say less glucose, or you can say maybe we can say less yeast is added, or maybe we can say less time. Many things can happen in this calculation, but not of reading measurement this one is the better answer. Predict the expected, so you get 13, probably between 8 and 18, so you get 13. Describe the relationship of the percentage. So what's the relationship? The relationship is 1 mark you get if the concentration is higher, then the volume of gas collected will be more. Or you can say if the concentration is higher, you give a higher volume, so you get 1 point for this, okay? Because the student say if the gas volume increase, the concentration increase when the concentration, so you get 1 mark for this. Another mark will be it remain the same after glucose solution is 10 or 11, okay? So this one is 1 more mark, it didn't say, okay? It remain the same at 10 or 11 percent of concentration, something like that you use your own word, okay? Use your own word. So it remain the same because probably no matter how much glucose you add, you still get back the same gas collected, okay? Suggest a piece of apparatus suitable for collecting the gas, okay? Gas strings, you will get 1 mark. The teacher repeat the experiment 20 instead of 40, suggest the effect, so there will be lesser, okay? Probably yeast will be around enzyme, probably work the best around 37 Celsius, around room temperature 20 Celsius also room temperature, but it's slightly cold, so it won't be that fast 20 Celsius, you know if you turn on your aircon, that will be the room, it will be slower. And if you put outside during the noon or evening, the enzyme, the yeast also will grow faster. Next question. Why the question number 1 so long? That's a very long question, number 1. A student prepare a sample of insoluble salt barium sulfate by reacting aqueous copper sulfate. So what he want to do? He want to make a sample of insoluble salt barium sulfate. So you want to make the salt. So what you need? So you need permit these 2 things, aqueous copper sulfate, they already give you, with aqueous barium nitrate. So you just need to mix it, and you got the salt. Measure 50 cm of copper sulfate, measure of barium nitrate, stir it, and there you get the salt with the liquid. So there'll be some solid at the bottom and also the liquid because they are using aqueous. Explain why 10 cm measuring is needed rather than 25, okay, to make the reading more accurate. Yes, maybe it's more thin so that you measure it more accurate. State one observation of the filter of conical fluid. So if you filter it, you will got something like blue color, probably the color of the copper. The residue of barium sulfide on the filter paper is impure. The impure residue contains soluble copper 2 sulfide. Describe how you purify it. You wash it with water. Okay, you wash the thing and it will become more clear. State the color of purified barium sulfide. This is a white color. Okay. The student tests 2 sample filter. Here is the page of the student. So the student do his own experiment. He do with sodium hydroxide with then he get blue precipitate. He do with aqua ammonia filter, give a blue precipitate. The student want to test 2 sample. Then a blue precipitate when a lot of sodium hydroxide is added, give a dark blue solution with lot of aqueous ammonia added. So these are the experiment that the student did. Present the table in the result. So you need to do a table. So let's do the test table. Okay, so these are the test table from the information. So this is not that hard So the test with aqueous you get blue precipitate. You put excess with sodium hydroxide, you get blue precipitate. You test with aqueous ammonia, you get blue precipitate. You do excess and lot of aqueous ammonia, you get a dark blue solution. So you can probably determine the salt, correct, the type of salt, and you want to do something like this rather than something like this. This one is you write in the notebook, correct or not? But in your science experiment, as we mentioned, for the result that you do, usually we put in a table, in a graph, in a histogram or what. So it's more clear to the person, correct or not? You want to see like this or you want to see like this? Usually it's like this first, okay? You give a table of statistics first. Usually when you study that time in a school, university, you will do your experiment, you will write something, and then usually something lah. Then you present the table. After you present the table, then you continue explaining the table. Okay, why more people like Samsung phone, more people like Nokia phone, more people like how many percent user. So you explain all your details of your business at here, for example. Then people read, also people happy. You want to, let's say you want to give a proposal to, you want to do a business, you want to give a proposal to an investor. Then you do something like this. Then the proposal say, why you know this business is successful? Oh, because I already do this, I got planning, 5 years planning, 10 year planning, and your return, accounting, everything you write properly. Not like everything in essay form, then people don't want to read your business plan already because it is so messy. You want to present a table. Investor only like how much they earn and they want to know the product successful, so we want to make it neat and nice for them to see. Same like this lah. This one is very neat and nice for science teacher to see. Oh, your research, right? Okay. Then people will like it lah. You explain it properly. Calcium hydroxide is a white solid, is added to acidic soil to increase. So there's a lot of word here. Even as a teacher, when I read a lot of work, I start to convert. I like picture. When they do experiment, they usually give a picture and the instruction. So when they give the word, we actually need to imagine the picture. No, if you cannot imagine the picture, then it's very difficult to do. Calcium hydroxide is a white solid that's added to acidic soil. Okay. Calcium hydroxide neutralize acid, such as what? So calcium hydroxide is just now what the student just write up there, right? Just now the student also write up here. Where is the notes? Up here. Calcium hydroxide. So calcium hydroxide is also lime water. So you are taking lime water. We are taking lime to neutralize the acid, usually in soil, because Yeah, to grow plant. So probably the soil, what happened is we use a lot of ammonia. And we also learn the process ammonia to make the fertilizer, and that is more acidic, uh, because you that is not a natural fertilizer. Natural fertilizer is maybe the cow dung, the bat dung, whatever, the chicken shit, whatever shit you put on it, then it won't be that acidic. But once you take a man-made fertilizer, so it will make the soil acidic, and probably you want to use calcium hydroxide to neutralize it. Okay, and once that is added to a acidic soil, so you can grow the plant. If not, the soil will be too acidic and you cannot grow the plant well. So you want to easy solve. Calcium hydroxide is also not expensive. You can easily get it at cave. So it's a neutralized process. So before this, if you still remember how you want to do neutralized process, so in my mind, I'm thinking of something like this, 2 and 3, okay? Neutralization process of 2 and 3. The reason is there's many ways you can do this. You can take a lot of beaker and then you mix it until you find your thing that you want. But if you do neutralization, it's easier because we just need to put the universal indicator to check the color. Very good. So we use universal indicator, probably from the red is acidic, around green is neutral. This one you need to remember lah. Blue, violet, dark blue is alkaline. So I like to use burette. Probably I need to just put the acid. Okay, so you need to put alkaline. Don't put acid. Put the alkaline in the beaker and you put acid on the burette. So you open it. So if you drip, as it drip, the color will change. Around to green color, you stop it, then you measure. So I like burette because burette you can control. You don't just use beaker, because beaker you also can, beaker you just pour, you wait lah, then you write down, then you pour a little bit, then you wait. So it makes the experiment a lot more harder. Burette you just on, off, on, off, on, off. Not only on, off, you will get the precise calculation of how much acid is needed to neutralize the certain volume of base, for example. You want to put here base first rather than you want to put acid, because if you put here acid, up here you put base, probably if you put little bit of alkaline in, I don't know lah, maybe not explosion lah, maybe the thing will spark out or the reaction will be more and something might happen. So you want to make it more safe, so you want to put the alkaline at the bottom and acid at top. So you do it slowly for safety purpose, because you are mixing the acid and alkaline. So you put alkaline in the beaker, not putting acid on the beaker. Then but this is dilute lah, so dilute probably nothing will happen also, unless you say it's concentrated, then it's a different story. Where was I? So this is the imagination. If you cannot imagine this picture, then it's very difficult for you to do the experiment. So I imagine this picture. Okay, so you need to write the apparatus, the description, what you will take, variable, and I don't need to copy the mastina, it's a very long, so I just give example of what the student write. Okay, prepare a beaker, glove, goggle, measuring cylinder. That's why the student lack of one thing is burette. Burette in this experiment is very important. Of course, you still can do, I say you can just use the beaker, but it makes the experiment so complicated. Even the book use burette, so burette is very important. But I just still give 1 mark because there is a apparatus, 1 mark. Put the acid in the beaker, measuring the volume, 1 mark. Then add calcium hydroxide, correct, 1 mark. Safety precaution, you wear goggle to prevent injury, 1 mark. Add your universal indicator to determine measure the solution, 1 mark. Do the same with different of calcium hydroxide, measure. So this one I didn't give any mark because I'm feeling like why you want to do that? Do the same with different calcium hydroxide, measure pH, the result in a test situation. I'm assuming the student say okay, so now I want to put the same, put more, and then I want to take a new one, or I put the same. So I just didn't give any mark lah, because actually I'm starting to confuse. Make sure the volume of dilute acid is the same as well as the one. So this one I start to confuse lah, so I just didn't give any mark. But for IGCSE there is no minus of mark, so they won't minus mark lah, they just won't give any mark. Record the result and you get 1 mark. If the pH increase, this explanation of result, the volume of carbon is increased, this conclude that the calcium hydroxide neutralize. Okay, this is the explanation, I give 1 mark. And for the graph, 1 mark. So eventually get some. So this one makes sense if you use burette, correct or not? Because burette you can calculate the volume more easy. This one also you should put acid lah, volume of acid added, and the constant one should be the alkaline, correct or not? Because in the beaker mah. But never mind, still can lah, still can. Maybe a bit more dangerous only because you say volume of calcium hydroxide added on the acid, so it's slightly more dangerous. But oh yeah, but one thing the student did wrong. Can you guess what did the student did wrong? One thing the student did wrong in this graph is, if you can guess, the student didn't use ruler. What is this? Why like that one? It's better you use a ruler lah. You see why? And then up here like 9 and 8 so near, and then 1 is so much, and then there is no ruler. But never mind lah. We still give it correct lah. But in science experiment we try our best to use ruler. It will take some time, but it's worth it lah. 1 mark only, 10 seconds, 15 seconds you will be able to finish it. Just simply use a ruler and draw it. But I still give correct lah, because it show that the student understand the experiment. So the student gets 7 marks. Many more things you can write but you can refer to the marking scheme if you want. So this will be the marking scheme lah. It's very difficult for the teacher to mark also, not like subjective because the point is everywhere. So if you got write this apparatus probably 1 mark or 2 mark. Here probably will give 2 mark, 2 mark, 2 mark, and 2 mark, something like that lah. So total will be 11 mark, but the maximum point you can get 7. So what you need to say is put in the SC, you get 1 mark, add calcium hydroxide, get 1 mark, stir it, repeat the experiment, the idea of using at least 5 different methods, save Google, protect, this one just now the student already say, measure calcium hydroxide, volume hydroxide, this one the student just now already say. Color, I'm not sure whether the student got say or not, okay? Match the band, this one the student didn't say, but variable the student got say, right? Make sure some of it is constant, volume of acid, volume of concentration of acid. Oh, this is the concentration of acid is the constant variable. So means you want to test the wait, let me read the question again. Calculate is neutralized acid. Calcium hydroxide neutralize the acid. Oh, because of this question, plan an investigation to find out pH value of dilute nitric acid. Dilute changes calcium hydroxide. Okay, dilute nitric, the acid change the calcium hydroxide. So you say that the volume of acid, if you want, volume of acid constant or concentration of the acid. Processing a conclusion. Draw a graph, okay, plot a graph, mass against pH, and so on, okay, the increasing of what, okay, so this is a pH and the volume. Okay, so probably you'll get mark for this. Okay, question number 4. A student investigate the rate of hot water coals. A lot of things. Okay, so this one you need to use your imagination, okay? Because at first when I read this, a student invested the rate of hot water cold. So how you want to do that? What other variable, like the movement of wind or what that you want to do, correct or not? Because of course if got, maybe I put one water with fan, one water without fan, so the water with fan will cool down faster. So the question didn't say, so let's continue to read the question. 304, the beaker in the room temperature. Room temperature will be around 20 to 30. Around room temperature, like your room temperature, probably around like 25, like that. Record table for the initial temperature. Have you record it out? Secure it. So this one you read by yourself lah. I want to read. Okay. After you do it, you get the thermometer, the beaker, the water, and the test tube. So the question asks, complete the diagram. So you need to draw the thermometer. So I give 2 marks. Actually, the water need to put slightly higher a bit lah. No need to put so low. Just put it higher a bit because the marking scheme say that at least the test tube water is half full. The water and water level below in the beaker. So here say half fill lah. So it must be half fill. I just think that is it like 2 down, or you got use ruler or not? But never mind lah. I got use ruler. Okay lah, maybe my eye problem. I thought it's slightly down, but that's why I put up a bit. Never mind lah. I think because it cannot float so I want to put more water so that it is what. But correct lah. This one is half, but maybe I think it's not half. I need to use ruler. Okay, so anyway, you got 2 marks for this question. Show the thermometer of 180 seconds. So of course, water in the beaker after 180 seconds it will increase. Correct or not? Water in the test tube will decrease, and water in the beaker will increase because heat is being translated out from the test tube. So you you write out the answer. You get 1 mark for the correct answer, 1 mark for the correct answer. Another 1 mark is for the decimal. So if you didn't put 0.0, you will get 2 mark. Okay, if you put 0.0, you will get 3 mark. So 1 mark, 2 mark, and another one is because the student got do 0.03 mark. Wow, very good this question. More question in the exam is very good. Describe one practical thing. Stir the water. Yes, you want to stir it so that it will be evenly spread the temperature. Suggest the temperature change. Thermal and kinetic energy is transferred to the test tube to the beaker. Yes, okay. Of course, the heat always transfer from hot to cold, like kinetic energy always transform one place to another to find the equilibrium. Correct or not? Eventually, you will find that after you wait for a while, maybe let's say it will get 25 Celsius, let's say, and both will be 25 Celsius because the temperature has reached an equilibrium. So the thing will transfer. Plot a graph. Do not start the temperature at the scale of 0. Okay, so the student plot the graph of temperature and hot water. So give correct, and the dot, correct, 3 mark. Calculate the cooling in the test tube. Draw a best fit line, 1 mark. Okay, so this one also is a best fit line, so this one get 1 mark. Calculate the rate of the cooling in the test tube. So the answer is 0.63. Okay, so of course you do properly lah, then you will get 0.63. So this one I didn't get correct. Describe of the rate of the test tube during 100 again. The rate will decrease. Remain the same, no. Describe the rate of cooling of hot water during, not after, during the 180 seconds. So we can say that during 180 seconds, the temperature is still, the rate is still decreasing. Not same. If same, the graph will be a straight line. So that is called same. But in 180 degree, it is still not same. We also know that the temperature in 180 degrees is still not equilibrium. 24.5 and 28. When all reach 27, 27, 27, 27, 27, then I would say it's the same. But now it's not same. So the rate will decrease. So that's it for this question. Thank you.